Hello and welcome to the lecture on a straight line gradient. What is a gradient? Well, a gradient is just the rate of change, or the rate at which a slope of a straight line changes. So let's say, for example, a man is walking down this, a man is walking down, across this road, and then suddenly it goes uphill. Well, the coordinates, that is the position which the man has stood in this area here, is different to that of the area which is here, that is at the top of the hill. And the rate of change, or the difference between these 2 points, is called a gradient. Here's that man walking, and the man wants to know what is the gradient because it looks like a very steep hill. Well, because it's a rate of change, we want to calculate the change in these 2 coordinates. So how do we do it? Well, let's say this first coordinate is our first point. So I'll just write 1, and this is our second point, 2. Well, the first point will have coordinates in x and y. The reason it's in x and y is because we're visualizing this gradient, this slope, like as if it were on a graph. It's the same as going. Let's call this vertical one y, which is known to us as y, and this as x, which is usually known to us as x. And as you can see, this problem becomes fairly simple. We've put the first point at the origin to make it easier. Origin meaning that y and x are both 0. So let's write that down. So we'll say x and y are equal to 0. And when the man rises, he's at a much higher point here. And at this point, let's say x and y have different coordinates now because the man has moved right and up at the same time. So let's say the new coordinates for x, he's moved 20 meters, and for y he has moved 10 meters. So he has moved horizontally by 20 meters and vertically by 10 meters. So vertically will be 10 and horizontally will be 20 meters. Because we know that the gradient can be calculated using the rate of change, this problem becomes fairly simple. All we have to do is find out the rates of change of the vertical component and divide that by the rate of change of the horizontal component. The formula for this is the following. Let's pick a different color. So the formula for the gradient is m. Remember, all gradients are denoted by the letter m. So m is equal to the second coordinate for the vertical component, which we call rise, and divided by the second component, which we call run, that is the horizontal component. Now, the change in the run can be equated by subtracting the original point from the final point. The final point is 0.2 and the original point is 0.1. So y2 minus y1, and the run can be calculated the same way. The original point in the horizontal is subtracted from the final point in the horizontal, that is this point here. So it'll be x2, which is the final point of the horizontal, minus x1, which is the original point of the horizontal. And we simply substitute in the values. The final value for the rise is 20 meters, while the initial value is 0, so minus 0. The final point for the horizontal is 10 meters, while the initial, the first one that we started off with, is 10, so minus 0 again. So we have left 20 over 10, and once we divide, we get 2 as the answer. So the answer is 2. The gradient of this slope is 2. It's quite steep. Therefore, we have just found out a way of calculating a straight line gradient. Just a few things to remember. When a gradient rises positively, that is, this way, so in other words, rises positively in the y direction, it is called, the gradient is positive. And the angle is called the angle of elevation. Because the actual gradient is above the horizontal. If it's a different way, where the gradient is in fact, let's extend this further down a bit, below the horizontal, the angle of this gradient is known as the angle of depression. And that's because the gradient is lowering and it is below the horizontal. It is decreasing. Let's try an example. Let's assume we get given a graph. We know that is y, that's x, and we have a line with initial values of, for the x is -1 and for y is -1 as well. Well, for the final values of it, y and x, we have, let's say, 5 for the run and 7 for the rise. And you ask, what is the gradient of this slope? Well, it's very simple. We go back to this formula. So the actual gradient is then m equals the rise over run. And we know that the rise is the final value of the y component minus the initial value of the y component divided by the run, which is the final value of the x component minus the initial value of the x component. We know that the final value of the x component is 7. So 7 minus, but here we have the initial component of the y is -1. So it'll be -1 over the final x component, which is 5, minus the initial x component, which is -1 as well here. So knowing our negative numbers, minus times minus is plus. So it'll be the same as saying 7 plus 1, so it's 8. And the same for the bottom, which will be the same as saying 5 plus 1, which is 6. And simplifying it down by 2, we get 4 and 3. And that's the gradient. So the gradient of the slope is 4 over 3, or 4/3. One important thing to remember is that the gradient has no units. It's simply a number. Do not forget this. Thanks very much for listening. Hope you join me next time for some more maths.